Hey guys, welcome back. This is going to be the second part of 3.1, which is representing relations. We're going to talk about the coordinate system and scales. When graphing on the coordinate system, the scale of the graph refers to the distance or interval between tick marks on the x and y axes. For example, one tick mark represents 5 units, and the scale of the graph is 5. Each axis may have different scales. A scale of one tick mark equals 1 unit is frequently used in math. However, using a different scale may make it easier to graph a given set of ordered pairs. So for example 3, they give us a set of ordered pairs here. So here's our relation. So to come up with an appropriate scale, we look at the x coordinates, and you'll see that they go from negative 36 up to positive 38. The y coordinates are going to go between, it looks like, negative 91 all the way up through 95. So that means for the x-axis, we want to include values as low as negative 36. So how about we go to negative 40, and as high as 38. So how about positive 40, just to make the math easy. The y-axis should include values from negative 91 up to 95. So how about negative 100 through positive 100? To complete step 2, we got to come up with a scale for the x-axis and the y-axis. So if we look at our graph, you can see we go 1, 2, 3, 4, 5, 6, 7, 8. We're going 8 in the x direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going 10 in the y direction. So we're going 8 in this direction, and we're going 10 in this direction. So how about we make the x-axis 5, scale of 5, because 5 times 8 is 40. So it'd be 40 in both directions. And we needed to see the y values are going 10, and we need to go up to 100. So 10 times 10 is 100. So how about we make that a scale of 10? Okay, for step 3, they want us to graph. I've gone ahead and filled out the graph. The x-axis, I did go by 5s, but I only put a number every other one so I don't get crowded there. I did the same thing with the y-axis, went by 10s, but I only put a number every other line. Now, one of the problems we have with graphing by hand is precision. So anything we have to graph in between our scale numbers is going to be kind of a best guess or approximation. Our first point is 5 and 80. Now, those land exactly on the scale line. So 5 and 80 will be easy. So 5 will be to the right 5 and up 80, which will give me a dot right about here. 36, negative 36, and 48. So I'm going to go left to 30 would be right here. 35 is right here. 36 is just a little bit past it. Then I got to go up to 48. So 50 is right about here. And I'm going to go a little short of that and a little to the right. So right about inside that box there. The next one is 25, 91. So to the right 25. I'm going by 5. So the right 5. And then down 91. So 90 is here. 91 is just a little bit past that. So I'm going to put a dot right about there. So we've done the first 3. The next is 38 and 95. So to the right 30. Almost to the last line here, almost to 40, that's 38, and then we're going to go up 95. So the 95 is landing right on this line. So 95 is going to be about halfway up, because this line right here is 90, this one is 100, so right about halfway up, just inside the line. 10, negative 10, negative 50, so left 10, down 50 should be an easy one. It's right on their scale axes, right there. And then 122. So 1 is, now we've got a 5 here. So 1 is really close to the origin. And 22 is going to be just slightly above the 2 here. So 122 almost looks like it's on the y-axis. Go ahead and pause the video and attempt the check. Okay, so for this one, when graphing these points, select the most appropriate scale. So the x-axis, what I want to do is find out what my min and max domain values are. So I'm going to put x up here. And my minimum was a negative 10 through a maximum, it looks like 16. So these are my min and max domain values. So I want to pick numbers that are close to that. Remember, I got to go low enough to include a negative 10 and high enough to include a 16. When we look at our answer choices, first one that seems to stand out here is this last one. We're going negative 20, positive 20, which is definitely big enough to include our numbers, but look at the scale, it's going by tens. We're not going to have enough precision there, so this is going to be way off. The C, letter C is pretty good. We got negative 12 to 18. Those are really close to my beginning and ending x values, but The scale is still too big. We're going to lose too much precision on that, so I'm going to get rid of that. So the last choice is, which of these do we go with? A scale of 1 or scale of 2? Well, let's look at our beginning and ending values. Well, negative 20 to positive 20. 20 is not too far away from the 16, but the negative 20, that's a little too far away from the negative 10. So I'm going to say let's go with choice B, since the beginning and ending values are really close to our beginning and ending x values, and the scale is still small enough to include enough precision. Y-axis, my smallest y values are negative 27 through 32. So the first thing we want to do is figure out what numbers are low enough to include negative 27 and big enough to include 32. We look at choice D here. Negative 30 through 40 is definitely big enough, but our scale is just way too big. Choice C is negative 35 to 35, which is definitely big enough to include, but a scale of 5. Now, that might actually work, but let's check the rest of them. B, negative 30 to 30. Well, this 30 isn't going to be high enough, so that's not going to work at all, regardless of what the scale is. The other one is negative 30 to 35, which is just like C, but a scale of 1. Now we're going to go from 30 to 35. That's a total of 65 units, so scale of 1 might be too small in that context. So I'm going to go with choice C here. Example 4, they want us to choose an appropriate origin. Okay, so the table shows the total snowfall for January for Boston. Has years 2005 to 2015, and it's got inches of snow. Choose an appropriate origin. Let X represent the, okay, we got years, so that would be years since 2000. It started in 2005, so the X-axis would be years since 2005. And the Y-axis will represent, well, that one's just total snowfall. So if we have this set up, the origin, which would be right here, would be 0, 0. That represents the year 2000, so actually the 2005. So years since 2005, so 0, 0 would be year 2005, and 0 inches of snow. So if this was a point on the table, the 0 would represent 2005, and the second 0 right here would be 0 inches of snow. Part B, choose an appropriate scale. Well, according to the table, snowfall is between, it looks like about 1 inch and 43.3. So between 1 inch and 43.3 inches. So the y-axis should include the values from 0. So we got to go low enough to include 0. And how about 43.3? How about we go up to 45 and have a scale of, now here's where we got to make a decision. If we go by ones, we have lots of little tick marks. So remember, we have our graph. We have our tick marks that look like this. If we go by ones, we're going to have 45 of those tick marks. That's a lot. If we went by twos, we're still going to have half of that amount. That's quite a bit as well. How about we just jump up and make it 5? 45 is divisible by 5, so how about we go to scale of 5? We're not going to lose too much detail here. Now they wanted us to graph this, so I've gone ahead and made my table. You'll notice I went every other line. So I'm still going by 5s along the y-axis, so I'm going by 1s along the x-axis. The year 2005 is 0 years since 2005, so it's 0 and 43.3, which would be almost 45. So 0, 43.3 would be right about here on the graph. The next year up is 2006. That's 1 year past 2005, so that'd be 1 and 8.1. So 1 and 8.1 would be just underneath the 10 here. 2007 is 1 inch. That's 2 years past, so 1 inch would be way down here. 2008 is 3 years past, so that would be 3 and 8.3. So 8.3 would be right around here as well. 2009 is 4 years past, so that would be 4 and 23.7. So 23.7 would be almost at 25. So let's call it right about there. 2010 is 5 years past, so 13.2, 5 and 13.2. So 5 and this is 15, so right about here I'd say. 6 years past is 2011, so 6 and 38.3. So 6 and 38.3 is right about here. 2012 is 7 years past 05, so 7 and 6.8, so almost 7 and 7. So 7 and 5 is here, so right about there. 2013 is 8 years past, so 8 and 5 it looks like. Yeah, 8 and 5 be right about here. 2014 is 9 years past, and 9 and 21.8 would be on the graph. So 9 and 21. So here's 20, 21.8. So right about there. And 2015 is 10 years past 2005. So that would be 10 and 34.3 on the graph. 10 and 35 is here. So 34.3 would be right about here. Okay, for example 5, they want us to interpret scales and origins. So below we have the average number of posts per day on a social media site each year is given in the table. Interpret the meaning of the axes, the scale, and the origin of the corresponding graph. So the first thing I want us to do is identify the x-axis. So what does the x-axis represent in this one? Well, the x-axis is years since 2008. So you'll notice the first year up here is 2008. So that's number of years since 2008. Because it is not appropriate to start at the year 0. We didn't start at year 0, we started at year 2008. So 0 represents 2008. What does the y-axis represent? Well, it's the average posts per day in millions, and that's also coming from the table as well. Okay, so the second part wants us to identify the scale. So the x-axis has a scale of 1 mark, which equals, now remember this is years since 2008, so this 1 right here must represent 2009, therefore the scale of 1 mark is 1 year. The y-axis has a scale of 1 mark equaling 2. If we look back, we've got a mark right here at 50, and remember this is in millions, therefore the y-axis would represent 50 million posts per mark. Okay, so the origin 0, 0, the first 0 here would represent the year 2008, 0 years since 2008, and the second 0 here would represent 0 posts per day. Go ahead and pause the video and attempt this check. Okay, for this check, the United States Mint is responsible for producing and distributing circulating coins that are used by people every day to buy and sell goods. Facilities in Denver and Philadelphia produce billions of coins each year. The table and graph show how many circulating coins were produced each year at these facilities from 2001 to 2011. Part A, interpret the meaning of X and Y axes in the context of the situation. So since we're starting with year 2001, the X-axis must be years since 2001. It has a scale mark of 1, which represents, okay, so we're in years, so this 1 right here must represent 1 year. The y-axis represents, now we're in the y-axis, which is the output, that's circulating coins produced, that's in billions, and has a scale mark of 1. Okay, so scale mark of 1, remember this is in billions, so if you look back at the graph, it's got a 2 next to it. So that 2 would represent 2 billion coins. For part B, they want us to interpret the meaning of the origin in the context of the situation. So 0, 0, this first 0 will represent the year 2001. Remember, it started in 2001. And the second 0 would be 0 coins produced.